All right. Hey, what's up, guys? Mr. Fortin here. Method number 1 of 3. I think this is the easiest method for doing number 26. So let's quickly run through it. So we're given that Kr to Rt is equal to Ks over Su, or Ks to Su, and we want to solve for that. So, right, the problem with this that they give us in this problem here is that we got part-to-part ratio and part-to-part ratio. Here, we know that this part here, Kr, is 12. We know that this part here, Rt, is 4, but we're given a whole over here. We're not given a part or a part here. So how do we set this up? How do we do this, right? We got 4 terms here within a portion, and you know what? This 20 kind of comes out of nowhere. So this is going to be the easiest way to solve this, is to realize that here, right, we know that Ks to Su, we know that this ratio here, Ks over Su, is going to be the same as Kr over Rt, right? That's given to us, given premise of the problem. Ks to Su is the same as Kr to St. So if we think about this ratio right here, this ratio here is any 12:4 ratio, right? Kr is 12, Rt is 4, and that's going to be the same as Ks over Su. So this would also be any 12:4 ratio, right? 12:4 ratio. So a more simplified way to write out a 12:4 ratio, of course, would be to simplify your ratio, and that would be a, what is this here? 12 with the multivisible by 4. So this is in a here, this is in the numerator would be here. So this would be in a 3-to-1 ratio, right? We divide both by 4. 12 divided by 4 is 3. 4 divided by 4 is 1, okay? So we know that this is going to also be in a 3-to-1 ratio, right? 3-to-1 ratio. So the easiest way, I think, to solve this problem is to distance Ks is going to be 3 times as long as distance Su. Well, what can we do then? It's going to be a 3-to-1 ratio. So we can actually define this as 3x, right? This is going to be 3x in length. This is going to be 1x in length, right? 1x in length there. 3-to-1 ratio. 3-to-1 ratio. Okay, we don't know what x is. Once we solve for x, we'll know what Su is. Then we just got to multiply it by 3 to get what Ks is here. Okay, so anyways, just to recap what I'm doing right now real quick, figuring out what the part-to-part ratio is on the left side here. I'm going to use that part-to-part ratio right here. And you know what? Check this out here. What is this all equal to? It all adds to 20. So that's how we're going to do this problem here. Ks, we're going to use the segment addition postulate in this one. So I'm going to do this here over the right side, because here we don't even have to set up a proportion to actually solve this problem. We can just do this. Ks plus Su is equal to Ku. And you know what? We know that Ks, right, needs to be 3 times as large as Su, right? Su here. Okay, so we can replace Ks with 3x, replace Su with x here, and basically we're just defining variables here. I'm not going to write out the defining variables like let x equal this and let 3x equal that, but that's the idea. This here has to be 3 times as long as that. So if this is in a 3-to-1 ratio, then this can be 3x for the time being, this can be 1x for the time being, and then you can just use your algebra to solve this problem here. So Ku, I wrote Ku a second ago. I didn't mean to do that because what do I know about Ku? Ku is 20, right? Ku is actually 20 here. So check it out. Real quick, let's solve this problem. 3x plus x, that's 4x, and that equals 20. Divide both sides by 4, and I get x equaling to 5. So what does that tell me about one of the two things I'm trying to find? Su is going to be 5, and that's going to be, right, because 1x equals 5. And 3x, what does 3x equal? Well, what's 3 times 5? 3 times 5 equals 15. So I got 15 for Ks. I got 5 for Su, and does my answer make sense? Yes, it does, because by the angle addition postulate, sorry, the segment addition postulate, 15 plus 5 would equal 20, right? Part plus part equals whole, and we're good to go there. This was an easy problem here. We didn't have to do this one, but we might as well fill this one in. What's KT going to be? Oh, well, KT is just going to be 12 plus 4, because the segment addition postulate tells you that Kr plus Rt equals KT, and that's going to be 16 right here. So there's your answer. There is method number 1. Maybe go back, rewatch this video, or watch the next 2 videos where I'm going to solve it 2 different ways, and maybe you'll get a sense of what I'm talking about in these 3 things by seeing it some different ways here. Stay tuned.